Well, welcome back to this next installment of the Meet the Experts series. I've been loving these conversations where I get the chance to pick the brain of some of the very people who I've referenced and researched in my writing of the most recent book I put together called Mindstuck. And the guest I've got joining me today, I remember speaking with early on in the process of working on the research and the ideas, and just found his perspective fascinating. Interestingly, so Mark and I'll introduce Mark to you shortly. He and I connected at would you believe this, a poultry providers conference a few years ago. He was speaking about what we're understanding and learning about pain, the way that the human body and bodies generally process and understand pain. Some really interesting stuff there. I was talking about the future and robotics and all the rest. But we connected, and I'm so glad we did, because I've loved following his work over the last little while. And I suspect you're going to find this conversation really rich and very interesting. So a bit of an introduction for Mark, and then we'll dive into the chat. So Mark Hutchinson is an Australian Research Centre Future Fellow and Professor within the Medical School at Adelaide University. In addition to his cutting-edge research in, and these words are tricky, I'm going to try and do them first time without issue, nanoscale biophotonics, almost got there, and neuroimmunopharmacology, how's that? Mark is also the president of Science and Technology Australia, which is the peak body representing 110,000 scientists across the country. So this is a man with a lot going on. He's got his finger on the pulse in terms of what's happening, not just in the medical world, but in science and technology broadly. And I was thrilled to be able to send Mark a or an advanced copy of the manuscript of Mindstuck, and was touched and chuffed that he put together an endorsement for it. So great to have you join the conversation. Thanks for making the time, Mark.
Always a pleasure to talk to you, Michael.
Well, you're very kind. Well, look, I'm keen to pick up on some of the research that you've done and some of your colleagues have done in the last little while about what we've learned about the brain in the last little while. I know you and I spoke about this when I was in the early stages of writing Mindstuck, because for the last few decades, because of functional MRI machines, we've sort of developed a series of assumptions about the way humans think. Some of that has had to be unpicked in the last little while. I'm curious, sort of, where are we up to? What have we learned in the last little bit about the nature of human thought and how we think as human beings?
And what we've learned in the last probably 15 years is more than we have appreciated about the brain for the centuries before that. And that is because of the realization that René Descartes back in the 1600s actually got it wrong. The mind and the body are actually connected, and you can't think of them as two individual separate entities. And that has really opened up a fascinating dialogue about how our biology interacts with our thoughts, our psychology, and then how that impacts the environment and how we interact with the environment around that. And this tripartite relationship actually then drives a lot of what we're now understanding is a much more complicated brain than we'd ever appreciated before.
And it's interesting too, because that whole notion of embodied cognition, and there's a lot of great research done on that in terms of how our physical bodies impact the way our brains function, the way that we think. Is that a fairly controversial thought, particularly for sort of purists who are, I guess, very focused on just the brain and how the brain does all the thinking that we do as human beings?
Yeah, so great point. So if I have been to scientific meetings in my career, which is only just on 30 years long, and at the beginning of my career, it was heretical to talk about the immune system of the brain or illness-changing brain function. Now, we've all just come through a pandemic and we've all had vaccinations, and we know that our response to COVID or the vaccine was different to our neighbours or our work colleagues. And that really came out from a question of how do we actually know we are sick, and how do we therefore respond to illness, and how do we compute that in our brains? And what's quite clear is we know we are sick. We all know we are sick to different extents, and how we feel is different. And so that has really broken down a lot of the commonplace societal barriers around understanding what our immune system is doing, talking to our brain. And at a fundamental neurobiology level, it's actually spawned a lot of really important conversations about not just the brain as a neuronal wiring or electrical organ. It's actually a neuro and immune organ. And by understanding that, that really opens many more front doors and back doors into our body changing our brain function. And then by changing our brain function, changing the way we think, which then completes the nice circle that the way we think changes our body and our body changes our mind. And then you've got this lovely feed forward or feedback loop, depending on how you look at it, to both change how we think through our body, but also change our body through the way we are thinking.
I love that. And it's so interesting too, because it sort of butts up against this idea that we often hear about of applying, I guess, a mechanical or a computer paradigm to the brain. We talk about people's wiring as if, you got essentially hardware that we're trying to reconfigure. And there's sort of an arrogance in it that we can pin down and completely understand the brain. And I think that arrogance is a tricky thing. And I'm curious too, going to your point about how you've seen the attitudes of scientists change over the time. And I know I sent a few days ago that article to you that was in the Sydney Morning Herald recently that was basically about this notion that if we're not careful, even blind belief in science, and particularly the end product of science, can actually almost be as heretical as having a faith in something that has no basis. That we've got to be super careful not to become dogmatic or ideologically driven, even when we're in the world of science. Do you see that play out? And what are the things that we need to be mindful of, all of us, so we don't fall into that trap of, I guess, being blinded by our ideology or beliefs?
So it's fascinating to see my brilliant academic peers have brains of concrete when actually we should be plastic and malleable. So there are certain rules in science that have been tested and retested, and they have become science law. But most of what we're dealing with in science is a series of hypotheses that we continue to test and retest, and some have stood the test of time, and others require further modification and embellishment over time. The challenge that I think we're facing at the moment, even more than sort of these breakthrough scientific discoveries of the past, is that we're actually having less and less of the profound scientific discoveries that are changing the way we see the world at a regular enough interval that we then get quite comfortable that, oh, well, this is pretty much it. We're doing pretty well in our understanding. And we've forgotten almost in science sometimes to remember how to be surprised. And so one of the things that I teach all of my students is if you're doing an experiment that you're not expecting a surprise from, it is not an experiment.
Wow.
You need to always be expecting surprise. But the problem is, Michael, that the time when you want to then make a decision is not when you're actually feeling the sense of surprise and wonderment. You want to actually have already thought about what the actual reason behind that surprise might be. So when I see people talking about processes in academic research or processes in scientific theory, absolutely have to base it on experimental judgment and the best practices we can, but we have to maintain a fluidity in our approach to our surprise and interpretation of the results. And rather than going, well, we didn't get the answer we wanted, so therefore we'll have to do the experiment again. Well, if it was a sound experiment and it was designed right, then maybe you need to accept the surprise as the answer and then go from there.
I heard this great quote recently, and it speaks to this very theme. I think it was Oliver Wendell Holmes said that it's the rare person who wants to hear what they don't want to hear. And that notion that I think for all of us, when you get confronted with, uncomfortable truths, particularly in a scientific environment where suddenly you get findings that don't match what you were hoping for, or maybe what you're even funded for in the science, there can be such a temptation to try and deny or just defend against or ignore that research. Have you ever noticed that personally? What do you do to try and avoid that sort of approach to ideas that may rub up against things that you otherwise might feel that you want to stubbornly cling to because they're things that you'd like to be true because they feel right?
Yeah, so I haven't been. I think I've been a rebel too long, Michael. When I first started in my postdoctoral training period, the immunology of the brain was still a controversial topic. Now, 90% of the cells in the brain are actually immune-like cells, not the neurons. And so when you see those videos of flying through the brain and all these electrical wiring cells all connected together, there's not space between those cells. That's the immunology in there. Now, I was always fascinated by that otherwise glue holding the brain together. And yet I was not concerned by coming up against the establishment who said the brain is immune privileged, the brain shall not talk to the immune system, full stop. And it was actually some of the people that I worked with and trained with, like Professor Linda Watkins, who actually speaks of being yelled off stage when she's described the immune-like brain, which now we take as commonplace. But this isn't some 18th century story. This is now that people are still getting yelled off stage because they're challenging the dogma. And I think that's where I've been always willing to take on the question if it's the right question to ask. And the right question to ask, I think, is, am I going to be surprised by the experiment that we undertake? And so that's really meant that my team and the people that I work with, I said, we always gravitate together to be those scientific rebels, always willing to ask the question. And again, going back to the point, if you're doing the experiment you already know the answer to, then why are you doing it?
Love that. It's interesting too. You talk about the example of Linda being shouted off stage, presumably by others in the scientific community and her peers who are learned and probably should know better. But I think the interesting thing is, even outside of that realm, we're seeing this happen, daily right now. And you see certainly in the popular culture and in the mainstream press, this is going on. And I pick up on this, and it worries me a lot. And I imagine it probably would you as well. This anti-intellectual bent that we almost have an unhealthy distrust for the experts. And I'm wondering, because you are across so much of what's happening in the world of science and technology and trying to raise awareness of the value of science, what are scientists and academics doing wrong in terms of not winning over the hearts and minds of people? And I guess then what are the lessons for any leader who's trying to get people on board with a message?
Yeah, it's been a journey I've been on for quite some time when I've been trying to communicate my science. And when I started, I honestly thought that I needed to dumb down my science to make it accessible. And that was completely wrong. And yet so many people still talk about making the science simple for communication. My sense is that in losing the complexity, we actually do disservice to those people who we are trying to communicate with, because by losing that complexity, we're also losing elements of the wonder and extraordinary excitement we have for that topic. So I see this as, rather than I'm going to didactically blurt to you for 20 minutes and you're just going to listen to me, but rather this is going to be a 20-year relationship that we have, actually in a two-way communication around where you're at in your understanding of this particular field and where I'm at. And there are certain things that I'm willing to speak to because I am a world expert in some things, but I know Joe and Josephine just over the fence who are far better to talk to about that other thing that you want to talk to. And that's a respecting of the disciplines and the depth of knowledge that's actually required to communicate effectively around science. Sometimes I think that in academia, we have isolated ourselves in these pure ivory towers of excellence, and we have, in many cases, iterated away from a relevance to the society and community that we are living in. But I'm seeing those ivory towers being broken down. COVID did a lot for that, because we can actually easily be pretty much anywhere in the world at any time now, virtually in 2 dimensions. But that is allowing for that communication and conversation actually to come through. And so I think of this now as scientific conversations rather than scientific didactic communication.
I love that. And I think it speaks so much of what we have seen over the last few years, particularly if you think about in a corporate world, suddenly leaders became accessible. You saw on video chats their cat walking in front of the camera. You got a chance to see their kids when they broke into the room to ask for something for lunch. Like, it was just these moments where people became real. And it seems that whether you're in the academic world or in the business world, wherever you are, if you want to win the hearts and minds of people and then win them to your ideas, so much of it's got to start with being accessible and real. I love that as a principle and just how important that is. Well, we're going to wrap up in a few moments because I'm very mindful of your time. Just want to thank you for firstly making the time today to chat, but also for modeling that. You're incredibly accessible, obviously very passionate about all that you do, but I love just how real you are. So thanks for just what you do, not just in your part of the world, in the world of academia, but more broadly. It really it's really making a massive difference. So yeah, and again, thank you for dialing in today.
Awesome. It's great to chat to you, Michael. And yeah, really enjoyed reading the book and hopefully making the book more accessible to other geeks like me who definitely need to have their thinking shaken up every now and then.
You're very kind. Thank you again. All the best. Cheers, mate.
Awesome. Thanks, Michael.